trust it. I would trust myself.
Just be careful.
Okay. Don't die.
Whoa. Can you guys see this? Can everybody see?
Hashtag in physics class with Mr. E.
Boy. Okay, if I make a wave, it comes back, right? I really want my long spray. It's so messed up. If you make a wave, it's gonna go to the end and reflect back, right? But it reflects back in the opposite phase than when it went there. So if you think of what a wave is, if you've got a spring and I pick it up, this upward motion lifts up the spring in front of it, right? So that energy is picking up the spring and it's grabbing the spring in front of it and lifting that up and lifting that up and lifting that up. But when it gets to the end, if that end is fixed, it can't lift the end up. And so if you grab your table and try, well, don't do that. If you grab one of these things and you try to lift up really hard, what happens? You go down, right? And that's what happens to the wave. If it hits that wave, the crest is coming, and it hits the more dense surface, it goes, and it reflects back in the opposite phase. So that's the phase flip. That's the inversion. Okay, thank you.
How do we determine this reading?
You know the densities of the materials.
That explains it.
Does it?
No.
Oh. You mean like how do you know if it flips or not?
Yeah.
If you're entering a material of higher density, then you will flip.
Oh, what's the... So in a bubble it will always flip?
If you're coming in through the air.
Yeah.
Not if you're coming in through glass.
No.
Because glass is 1.5, right?
But in a bubble it's always in the air.
In the air, yeah, it's always going to be flipped. Yeah. So in the air, you're right. In our example, we're coming from air, which is a pretty low density, into a higher density. So your N is higher, right? If your N is bigger, you're going to have a flip. So turn to the person beside you and tell them where there's a phase flip in this drawing.
I just have one question. Then why did it even go through the first layer of the bubble? Because the first layer.
Oh wait, no, you're right. Only if it's that way.
You have 10 seconds to sell. You're on video. What do you need?
Okay. So does
So
the
now
phase
I'm
flip
understand
is
this one. This one, is it okay? But it's not
First,
But not this double the wing point.
So this is straight down, right?
why doesn't it flip every time?
This is also straight
Because
down.
only if you're going into higher density.
But it's
If you're
going
going
to,
from soap
you're
into
going to
the
have
air,
to
then it
monetize the
opens
straight down one into
So you're going
the perpendicular one.
Yeah, but it's not like, why is it even associated with
water? So it's
Yeah, it's not happening.
Yeah, but some of it is going in that way.
Yeah, and stuff that does go theta.
But then that goes back to the soap. Yeah, it's like it's not like go away from your transport. You know, why does it like up and it doesn't fast? It's still going up. Because you're going more dense than the air. So it's up and it keeps going back up. But if you go to another person,
Maybe
because the bubble is just goes down.
Maybe, we'll see. Is there a phase shift here?
No.
No. Good. You're reflecting off a lesser dense material. So it's just going to come back at the same phase that it was. Is there a phase shift here?
Yes.
Yes. For the reflected ray only. There's never a phase flip for a refracted ray. It's only if it's being reflected back.
But it's still flipping though, right?
This one is flipped.
Yeah.
Okay. So let's write that down here.
So
This
we're
guy is going to be... So he's flipped, so when he... I shouldn't say he. I don't know what gender photons are.
Just being doing the second time.
They, when photons... Don't call it it, that's so mean.
It's not a person.
We don't know
It's
what
a
they are.
photon.
We don't know what the true nature of light is.
If we're in Canada, can we just find out what gender French associates with it and then just use that?
Oh, interesting. Someone find out the gender, the French gender of, it'll be masculine.
Masculine.
It's masculine.
Everything they don't know, they just make masculine. It's patriarchy all over again. This one's coming back flipped, right? So what that means is that to get constructive interference here, this no longer has to be one wavelength, right? It has to be half a wavelength because this is shifted now.
Wait, why does it shift?
Okay, so let me explain a little bit. Let's say this ray is coming in here as, we'll say, I'll write C for crest, okay? Can you guys see that? I'm getting right into the details here. Let's say this wave is coming down, it's going crest, trough, crest, trough, crest, trough. And when it hits here, it's a crest. The instant it hits, it's gonna flip into a trough. And you're gonna have a trough going back. Okay, so this is now trough going back. Going into the soap bubble, it's still a crest going in here. It hasn't flipped. The refracted ray has not flipped. So this is still crest going down. So if you think about it, we only, to get from a crest to a trough, how far do you have to go? Only half a wavelength. So this shift only has to be a half a wavelength because then you're going to end up as a trough going out.
So the T has to be 1/4 of a wavelength?
That is correct. Yeah, your thickness here is only needs to be a quarter to get constructive interference because you go down a quarter, up a quarter is a half, and because of this flip, you should get constructive out of that. Okay. So that's the two things, and there's a third thing. The third thing is,
Do the colors happen when they're not like aligned?
say that one more time.
Do the colors happen when the wavelengths are not, the waves are not aligned? So they're shifted but not by a wavelength or half a wavelength?
I'm going to answer that question in 1 minute, maybe 2. Okay, so the third thing to remember is that the wavelength is changed inside the new medium. The reason for that is because when you enter a new medium, will you tell me what happens to light when you enter a new medium? It slows down. In this case, you're going to slow. Velocity stays the same, but what equation is always true with the wave? Good. This is always true, right? The frequency has to remain constant coming into a boundary and going out of a boundary. You can't just create a crest out of nowhere, and crests don't just fall apart. So if you have going in, you have to have going out, but it's moving slower. So you have coming in fast, wham, 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 and going out, it's like wham, 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 right? So because that, I'm saying this wrong, but the frequency of the number of crests going in has to equal the number of crests going out. But the distance between those crests is going to change. If you're moving slower, that's right, it has to be a shorter wavelength. Because you're creating the same number of crests, but you're moving slower, so that crest is traveling a less distance before the next crest is formed. Does that make sense?
Yep.
Okay.
Does the T have to rely on the density of the new medium essentially? Like if that one distance only works for that certain density, correct? Like for T to be 1/4 to get constructive interference leaving, if the density of that medium is different, then that wouldn't work because.
Correct.
Okay.
If you change your medium's density, then it's going to change.
how do we calculate this?
Okay, so let's do this. So let's say we shine, let's just stick with our present example and let's say, well, okay, do you want to go through the formula part or do you want to figure it out yourself first?
Figure it out.
Okay, let's try to figure it out. So let's say we shine, what color light do you want to shine?
Pink.
Yellow.
Pink? What is pink?
Green. What's yellow?
Okay, let's do yellow.
I think like one of the colors doesn't exist, it's just our brain.
What wavelength is yellow light?
No,
Right, cheap. It'd be kind of in the middle, probably like 550, right? Into a soap film. So let's say that's 550 nanometer wavelength. At what thickness T, and this is in the air, surrounded by air, at what thickness T will we see constructive interference? Actually, I should say what minimum thickness, because of course there will be other thicknesses, right? Oops, sorry.
Is that a frequency or
Lambda. Frequency is, you have to figure out what this.
something? How do we calculate velocity though?
You don't really need to calculate the velocity, you can cancel it out.
That's, but yeah, if you can't write it down, how are you gonna?
550 nanometers is the wavelength of the yellow light.
Yeah. We'll say.
And then, was not gonna. And over C
Yeah. How about a pencil?
That works as well.
Mm.
Shouldn't the wavelength be like reverted to back like what it was before when the second light comes out of the bubble? Because like it's changed inside the bubble and then it should be like
Yeah, once it comes out, it'll go back to the same.
so like why do we care like what the wavelength like inside the bubble is?
That's a great question. So let's say your wavelength is 2. You come down here and then your wavelength changes to 1 when it's inside here. Okay, so if my wavelength goes to 1, this only has to be half of 1, right? If my wavelength stayed the same, if this was 2, then this would only have to be half of 2, which is 1, right? So the thickness that you need is different because the wavelength in here is different. the thickness you need for constructive is all about having a phase shift that will line up with the trough here, right?
Okay.
So in this case, we need a half wavelength, we need this there and back to be a half a wavelength.
Yeah.
And so because this wavelength is what's inside here, our new wavelength, then it matters.
Oh, okay, okay. That makes sense.
Yep.
Does this, am I making gibberish? Or does it make sense?
Maybe. V over F, yes. And you're gonna have C over N2F.
That's cool.
I think you gotta secure everything in there. You need to find the new wavelength, right? That's what you need to find.
Yeah, that's, what was this
V2
called?
over F, yeah.
What is this called?
Lambda.
Lambda 2,
Yep.
so V2 over F.
Mhm.
And I found the F using the first wavelength. So if I have the first wavelength, if I have the N values and if I know the C, which are all constant, I can find the second wavelength, and then the T has to be a quarter of it. So constant, 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 given. Wouldn't that make sense? If I know these two. I thought the C values would cancel out, but they didn't.
I feel like the C should cancel.
Yeah, that's what, because V equals lambda.
Well, I'm gonna stop this because it's getting too long. It'll take forever. Now, this part 2 is done.